Okay, let's go ahead and get ourselves started. We're going to have some fun today, hopefully modeling some other types of systems that are typically parts of buildings. So we've been looking at structural systems and architectural elements. Today I'd like to plunge ahead into just really modeling of plumbing systems and HVAC systems. So all the different pieces that need to come together to ultimately support the building as a living organism that's going to take care of all the needs of the occupants. So we'll start by just creating sort of a very simple little building. Actually, I'll open a building where we actually have some of these systems detailed already. We can try to learn from the examples for each of these different types of systems. It's very helpful to start with just really what the principles are, really what the science is behind the systems and really what sort of things drive the design of these systems. Because as soon as you have that stuff down, actually doing the modeling is the least of your worries. The modeling actually is pretty easy. And if you're having trouble modeling these types of systems, it tends to be more related to the fact that you're trying to have the model do something which either physically isn't possible or doesn't make sense, okay, than anything else. It usually is related to something like that. So if you understand just the principle behind it and how these systems are typically designed, it gets a lot easier to model them. Okay, so we'll go through and take a look at those things. So there's two main types of systems we're going to be looking at today. We're looking at HVAC systems and plumbing systems. And we're going to go ahead and just open up a model that has both those systems in it a little bit. We'll talk about some of the design considerations that really drive those things. So I'm going to open up Revit. And the model I'm going to work with, it's actually in the session 15 folder right now at OnCoursework, if you want to open it up and follow along too. I'll start by opening, there's this little architectural building. So if I go out to that section 15 folder, I have a copy on my local machine, but it's a duplicate of what you have out there on coursework. You'll find there's the architectural model. Let me open that one up again to remind you what that looks like. So here's the little architectural model of the building. Again, we have some retail space with some office space above it. But as part of this system, if I look at it in floor plan, you can see there are some cores set up to the building. There is not only some circulatory space, but there's some basic bathrooms sort of set up for the building. You know, a men's room and a women's room that have a sink, a urinal, a couple toilets in there. So a very simple bathroom design. Okay. And we also have, if I look at a section of the building, take a look at that. A little bit of ceiling space, a little plenum space within there, where somewhere between the ceiling and either the floor above or the roof above, there's some space where we're trying to run some duct work, there's space for us to try and run some structure, things like that. So let's take a look at a model which is more developed and see what we can learn from it. I'll open up, the parallel to this is actually the MEP model. See if we can make sense about how these systems work. Now, this model, which currently is just showing the plumbing fixtures and a little bit of MEP systems for the building, okay, has those features abstracted out. We can keep these all together in a single model file, or we can link some models together. We're going to learn about this whole notion of linking together model files where when people work from different disciplines, if they don't actually want to physically share a single file, I can take your model file and link things into it. Use your model as the basis, but then add my elements in it, and we can kind of control those things individually. And that's a very useful way of doing things. If we don't all work for the same firm, you know, there's something nice about I'm controlling things that I have explicit control over. I can see your things, I can sort of reference the locations of your objects, but I can't actually get in there and change your objects. So organizationally and just legally, that tends to work out to be easier to set up projects so that we link files together as opposed to actually just all working and sharing the same single file. Okay, so if I just want to sort of see how these things are linked, what I can do is, I have that architectural model, because in the background, this really is how these things got set up. Let me take that architectural model. I'm going to close it right now. And the reason I'm closing it is I can't actually have it open for editing and also link to it at the same time. I just have to sort of address it one way or the other. And what I'm going to do, I'm over here in the MEP model, Let me link it in over here. When I want to link files, there's this option of inserting files into other types of files. And if you're familiar with the drafting world, this is very similar to in AutoCAD how you XREF in other files. You bring things together where I want to be able to look at those things. I'm not necessarily going to edit them, but I'm going to have them in there as the basis for, kind of positioning things relative to the things that are in the other file. It's really more of a point of reference. And I can link Revit files together too. So for example, I'm in an MEP model. I want to link to that architectural model and see my MEP elements and context of it. So I can choose that architectural model. When you link things together, it works very straightforwardly, except for one critical choice. And I even made the mistake last time here in class, of not kind of choosing this right, because every once in a while I get very quick and just sort of forget to make this change. You'll notice that the positioning between the different files is by default set to auto center to center, okay, which sounds like it would be a fantastic choice, but it actually is rarely the choice you want to make. Center to center says if I have two different model files, find if you can think of the center of mass, or really the center of the XYZ space in that one model, and find the center of the total extents of the XYZ space in the other model, and bring those two centers together. Okay, the same point. And there are so few cases where that is actually what you want to have happen. Because as soon as in either model something's a little taller or a little broader, all of a sudden those centers don't match up. So rather than going center to center, which you almost always want to do is do it what I'll call origin to origin. We're in by a shared coordinate system. Origin to origin says if your model was created with the XYZ 0 in a single place, and my model was created with the XYZ 0 in the same place, I'm going to bring them together so those 0 points actually line up with each other, regardless of how much geometry was created. Okay, and is that?
What if they weren't digital? How do you know that they have the same origin?
If they don't have the same origin, then we're going to have to do a little transform to them, and we can actually sort of put things together. We have this ability I can share your coordinates across and do a little manipulation to sort of say what the transform is between the two of them. So if they didn't come from the same place, I got a little like 4-step procedure for how to get them to line up. Okay, but we'll save that one because we do need to do that. If people generated them completely independently of each other, we can bring them back together. These I happen to know came origin to origin, so let me go bring them in that way. What's happening here, it's a little hard to see in this view. But if you rotate it around, you can start to see that the overall building plan's there, the toilets are in the right places, the air handling equipment's in the right places. We have those two things just kind of lined up with each other. So we get the two different models together, at which point we kind of pop back out again. The HVAC systems are there. I can get to all these different all these pieces of the HVAC system, the ducts. I can go through and get to the plumbing fixtures and things like that. The linked model, though, I can't really get to. Let's talk about that. Linked models have this funny quality of them. You can look, but you can't touch. Okay, and that's it. We can choose it, but if we want to go through and do something with that, we can't really get into changing the linked model. Okay, we can select it as a whole, operate it as a whole, but you can't really get into actually moving those doors and windows around. And that's by great intent. I don't want you to go ahead and start moving around the architectural elements if you're working on the MEP pieces. It's really kind of a control issue more than anything. But with this as some overall context, let's talk about the two different types of systems that we're seeing here and see if we can sort of figure out, a little bit about how they're designed, kind of based on what we're seeing. So in this model, let me even zoom on in there a little bit. Okay. Those are plumbing fixtures actually at the second floor right now. So this is the men's room over on the left side, that's the women's room over there. You'll see a couple different types of piping systems kind of all happening in here. Let's see if I can shade these and kind of make it make any more sense. They're shaded, That's not showing it there. Let me try something in terms of filtering it that may make it a little more visible. No filters are set up. Let me do this. Filtering is kind of a very interesting thing you can do that a lot of models do have set up for them. You can set up filters that basically control, how different types of systems, how things are displayed based on different qualities that you can select as part of like a database search. So for example, if I went ahead and choose the domestic cold water filter, okay, and I can even take a look at really what that is. Let me see, edit it. That's anything which is assigned to the cold water system, okay, as the system classification is domestic cold. Okay. I can go ahead and give it some sort of override. So, for some sort of pattern, let me go ahead, I'm just going to show that in deep blue. Okay. I'm going to do a similar sort of thing. I'm going to add another filter for the hot water systems. I'm going to override that so it's showing in kind of a nice deep red color. And my final one, I'm going to look at the sanitary system right now. I'm going to override that so it shows in sort of a green color. Again, what's the point of doing all this? It's really just to kind of make it sort itself out visually a little bit. Let me see if I can get these to actually work. Looks like it's not showing it to me right there. You are part of the sanitary system. I believe I've turned on the filter.
The shortcut for visibility graphic is VG.
Yes. What am I doing here? I'm expecting those to show for me, but I'm not seeing them showing right now. Oh, make it a solid blue, as opposed to just the skinny one. VG, or it's interesting, I say VG. People who've learned Revit more recently say VV.
So is it VG or VB?
It's either. Just to make life confusing for you. So now we see a little bit more about, how the different systems are. They're kind of color-coded in there. Let me turn off the visibility graphics of the other model, just so it's not bothering us right now. So I got a couple different sorts of systems in here. I have the sanitary system, I have some water systems, some red and some blue. Got some really interesting graphical thing going on there. I'll figure out why that is in just a second. That looks very strange to me. It's almost like I have two things on top of each other, which I probably do if I think about it. But I don't know. We'll figure out why in just a second. Okay. If we look at this system, let's talk about how systems are typically designed. If we go through and you think about your average bathroom, a typical bathroom, maybe we'll have a series of different wall-hung toilets that have some sort of a flush valve up there. We'll have another sort of, these are very kind of like sketchy graphics for how this works. We'll have, maybe a sink over here. We'll have some sort of urinal over here. Okay, let's think about all the different sources and things that happen. The idea is we typically go through and we have some sort of sanitary system which really carries everything away. And what you're seeing here is that for each of the different fixtures, from the toilets, typically we have some sort of sanitary coming out the bottom. Even for the sink, we tend to have some sort of sanitary coming out the bottom. Now, the size of the sanitary line coming out of each of those different fixtures is a little bit different. Like for the toilets, it's typically they're 3 or 4 inches. It's much bigger because you have to remove solid waste. So you have some big old systems that are necessary to kind of carry away the waste there. Yeah. A urinal, since we don't have solid waste, tends to have a much smaller line. They could have like a 1.5 inch line or something like that. Okay. Same thing with a sink. A sink tends to have a fairly small drain line coming away from it. Okay. All these things won't drain individually kind of down to the like a sewer system or out of the building. What we tend to do is actually tie them all together. So we tie them all together with, this would be called like a lateral that's coming across, and then it goes ultimately to a riser that connects things up and down throughout the entire building. So just different terms of terminology. Like when things are running straight up and down, I'll call that a riser. I tend to call that a lateral. Okay, so that all kind of works together. As you go through and do this, the size of the pipe that is necessary to carry everything away tends to be determined just by how much load you're putting onto it based on all the things that are adding up. So, if I have many, many loads that are going to be contributing to the pipe, this pipe's going to have to keep on getting thicker and thicker. And what will often happen is it may be smaller at the end because it's only servicing a single load, but as you add more loads to it, as you head towards the riser, it will keep on getting thicker and thicker as you need to keep on allowing additional capacity for things that could come from each of those different fixtures. So we tend to have pipes that come on down. What will often happen, at least in a sanitary system, is like a 4-inch pipe is so big that it'll actually be big enough to go through and handle all the loads or the projected loads, because unless we were all flushing continuously all the toilets at exactly the same time, there's sort of this like offsetting. Very few times do you actually have all the loads sort of contributing at exactly the same time. So usually like a 4-inch pipe will take care of these things. But as you have smaller pipes joining in, you have all these funny little connections, little T's and things where you have to get all the different little pipe connections fitting together. The other thing you have going on is you'll notice that the lateral isn't horizontal, it's actually sloping. Okay, it's important that from the end, moving towards the center, it has a little bit of slope so things run downhill. Okay, that's basically how sanitary systems work. Okay, this riser will go on down from the building. You may go directly to some sort of sewer connection or something happening down in the lower levels of the building in the mechanical space, or pumping things out. But we're going to kind of allow that to kind of just be handled in a different part of the building. Okay. On the other hand, the water systems are a little bit easier in terms of the water supply. You'll find that, toilets and urinals, they just have to be supplied with cold water. That can actually tend to be a very small line, like an inch line or a half-inch line. It just really depends on how much flow you have to be able to provide. Okay? Sinks, they have even smaller lines. It tends to be only cold water and hot water. Sinks, you actually have sort of very interesting things. Sometimes we supply hot water from a central water heater and have a hot water line running. A lot of sinks in commercial spaces don't have hot water coming from a separate source. They have a little hot water heater just right underneath the sink, which is supplying that need very, very locally, just at the sink location. But in your average bathroom, the only thing that actually needs hot water is the sink, just for washing your hands. Okay, now this all sounds kind of mysterious. How are you going to know all this stuff? There's really a lot of information kind of encoded in like what it might take to create one of these systems. And the cool thing is, each of the different parts that you put together actually has some information associated with it. So for example, a typical urinal, you can see it has 5 fixture units. That's a measure of how much water is going to go through it. And it's going to require a 3/4 input. I'm not sure what the output's saying right there. I think it's actually saying something right there. Out is 4 fixture units. It's a 2-inch outlet. If I go to the toilet, you'll see that it's 10 fixture units in and a 1-inch pipe, 4-inch out, contributing 4 fixture units. The way fixture units are measured, it's different for the supply side and the output side. Okay. If I go over to the sink, you'll see, it actually has a couple different ends. It has a hot in and a cold in. The hot and the cold are both 1/2-inch ends. The out is like, they're trying to say 1 1/4. I think it's something like that in there. But for each of these different fixtures, let me go ahead and open one of these fixtures. If you edit the family, you'll see all that information is encoded in here. Let me see if I can find something that shows it to you nicely. That's the radius and all that. That's okay. I'm just trying to figure out the sizing. There's the fixture units. The radius is 1/4. Let's see about this one. That's 5/8 inch. Oh, come on. Da, da, da. Water. Da, 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 da. Okay. What's that? Oh, in this case, it was done with the parameters. But you can sort of see that, yeah, they're controlled here in terms of the diameter of what's coming in, 1/2 inch cold water coming in, 1/2 inch hot water coming in, yeah, and in terms of the sanitary, the radius is 5/8, so the diameter would be 1¼ inches. So it's all done as part of that part definition, but this notion of how we connect to a hot and a cold water, like a tap, is actually encoded as part of the fixture. Let me open up a different one too. In the same sense, let me open up one of the toilets. So again, it has a couple different things. I can look at it either through the properties. I can look at it in terms of how things are divided. Like the sanitary diameter is 4 inches going out. The cold water diameter is 1 inch. Okay, so that's where it's actually figuring out the sizes of the connections that it's picking up and trying to put together. So in terms of trying to put together these connectors, let me, for example, say there's going to be a pipe connector to this. I'll put it on the face of something. Yeah, I put a pipe connector. It doesn't make sense to put another one there, but just so you sort of have a sense that I did put one there. You know, what is it? You can get a category, for example, if I wanted there to be a hot water connector and a size to that. That would basically say I have a hot water connection, you know, to the toilet. That doesn't make sense in this case, but that's how these get added into it. And those are actually then used as part of the piping system to try and figure out just how much the capacity is going to be and ultimately aggregate it up. Let me go ahead and close that up. So let's talk about how you actually model something like this. That's kind of where we're heading towards. Does it sort of make sense at a high level? Okay, this is working? Beautiful. Okay, let's go ahead and see if we can model a basic little bathroom and put that thing together. So to do that, how about this? We can keep on working with this more complicated model. I'm actually going to go through and just create another very simple model, just kind of make it a little less obscure about how things came together. I'm going to say, I'm going to do a mechanical template project. That's the mechanical template, as opposed to the architectural template, has a lot of good parts loaded in for doing plumbing and doing HVAC and ductwork and stuff like that. So if you take your architectural template project and you start doing ductwork, it may say, you know, I'm having a hard time routing all this because it's only as smart as the number of parts and sizes that are loaded into the project. Okay, so if the architectural project doesn't have a whole lot of ductwork sizes or piping connections loaded into it, it may have a hard time making the connections. Whereas if you start with a mechanical one, it has a lot more families that are related to plumbing types loaded in there. So it'll have an easier time making all the connections. In fact, let's even talk about what it's going to do. Okay, on the one hand, it's going to say, hey, you got a 4-inch pipe over here. You're going to draw some sort of 4-inch pipe going over there. It's going to go through and make some connection between them and try and figure out some sort of an L or an elbow or some sort of connection in terms of making that. Okay. Revit's only as smart as the parts you've given it to work with. So if you give it a nice wide variety of stuff to work with, it'll do its best to figure out which piece can connect those things together. Yeah. If it doesn't have much to work with, it may say, I just don't know I'm not sure how to connect those things together. Okay, so you know, when you're doing this kind of work, you know, one of the critical things is give it a nice library full of stuff to work with so it can try to do the auto routing. Okay, as much as possible, yeah, that actually helps it out quite a bit. So we'll say mechanical template. I'm just going to create a basic wall over here right now. It could be just sort of the generic wall, or it could be sort of a more interesting wall. Let me zoom on in here. I'm actually going to create 2 walls, actually. The reason I'm going to do this is, as we start trying to route pipes and fixtures and things like that, if I only have a single wall thickness to work with, it's very hard to have everything like get into that single 6-inch wall or 8-inch wall. What we often do is actually have two walls where we have a little bit of a buffer space behind the first wall to hide all that plumbing behind the wall. So an awful lot of things in residential work, we don't typically need to do this because the fixtures and the connections are so simple. We can just get it all within the stud depth of the wall. But if you start thinking of almost a larger commercial space where there's an awful lot of piping going on, there's actually a couple different walls in there. The wall you see, and then a little bit of a mechanical space behind it. Or even like, in a lot of restrooms, which is really kind of cool these days, they'll go into the restroom, and there'll be a urinal or something, but it'll be something like this. The urinal will be hanging out here on the wall, but there'll be like this little shelfy sort of space on top of that. You sort of wonder what that little shelfy space is all about. And the reason it's there is actually all the piping is running around inside this space. And we have good mechanical access to that can pop that shelf off and kind of take care of everything. It's just trying to provide some mechanical space. So it's good to be able to give yourself access to the mechanical spaces so that you don't have to go tearing into the wall anytime there's a plumbing problem. Okay, so that's why I'm going to make a little double wall construction here. Okay, in my little bathroom space, let's go through and put some fixtures on the wall. I'll go for components. Let's see if I can, let's see what I even have in here. Got all sorts of stuff. Other toilets? It's almost too many things to look at. Let me load in a family. I will go out to the mechanical equipment or plumbing. I'm going to go to the MEP version of the fixtures. There are two versions of the fixtures. I should test this to actually see if this is still absolutely true. Let me load in an MEP version of a water closet. Let's say flush tank, flush valve wall mounted. So load that on there. Got a couple of, those are my MEP versions. Let me go ahead and load in the other ones. I'm going to load the family. I'm going to load the architectural ones. So US Imperial, plumbing, architectural, I'm just doing a little test here because I'm not absolutely certain what the answer to this is. Okay, at some level those should look very, very similar to each other. Yeah, kind of just 3D it and go from there. Okay. Let me try this. That has fixture units. That has fixture units. This one doesn't by default. Okay, so watch out for this. When it comes time to actually start doing the routing of the piping and stuff like that, the normal old toilet that you put in there just by pulling it from the architectural library may not have the plumbing connectors on it that you need. Now, that's not to say that you can't add them back in. We can edit the family. If you've already put a lot of the architectural toilets in, you can always go back and edit the family and kind of put the connectors in. Or we can go ahead and replace them. Either way. But there's the difference between ones that are sort of activated with the extra information to kind of do a plumbing system versus ones that are just sort of by default. So watch out for one. That'll get you. That's what I sort of wanted to test. Okay, so I have these toilets hanging on the wall. Let me go ahead and load in a couple more fixtures. Let me load in first a component. Let's see, I'm going to get the plumbing version of it. So plumbing MEP version of it. Let me go ahead and get that urinal. Wall hung with wings. And then finally, let me get some sort of sink. Load a family. Again, go out to the plumbing I can go to the MEP library since it's going to have a little more answer. Certainly.
So, what's the difference between being in the architecture, clicking a component, and then adding the families that way versus being in the systems tab and then clicking on the particular component you want, like plumbing fixture, and doing it that way?
Oh, that's actually a good question. There's really, the only difference, let me put this in here, is really just, what it's going to limit things to. So I'm in architecture, I'm saying component over here. It's giving me access to the full list of stuff over here. Just a very broad list of everything. If I'm over on the systems tab, and I say that I want to put in like a plumbing fixture, in theory, this is going to be limited to only the plumbing fixture. So it's just filtering it for you a little bit. They're all ultimately components. They're just components of a type plumbing fixture. Okay, and all these different little tabs. I go to the systems tab. I'll say plumbing fixture versus a sprinkler versus a cable tray, or an air duct. Those are just subcategories of component where it's just filtering them down, so you're only getting sort of the things that are most relevant. So, very good question. There's really not much difference. Okay. So, I'll pop that one up a little bit higher. Okay, so we got some basic fixtures hanging around in here. We are ready to start routing them together. So again, each of the different fixtures has some sort of notion on the back of really what the ins and the outs are. So we are going to go through and start putting some systems together to make this all work. Okay, so if I want to start with, for example, the sanitary system, let's think about that. I'm going to want to put some line in here. I'm going to put like a 4-inch sanitary line kind of coming across the back over here. But I know it has to be at least 4 inches because the toilet's going to require a 4-inch out. So I'll go for a nice 4-inch system. That'll probably be big enough to take care of the capacity. If it needs to size it up, ultimately Revit will tell me. We can actually get it to size things based on the total number of fixture units. So let's go ahead and put this in. Let me zoom on out. I'm going to run this line actually not underneath my toilet, so I'm going to run it back here in the little mechanical space, kind of in that space that I've set aside to make this available. So what I'll do is I'll say I want to choose some sort of piping system, and let's just pause and take a look at all this, because there's a lot of information available at this point. We have different types of pipes, standard pipes, chilled water pipes. I'll go for a standard sort of type. We have sort of which system your pipe is going to belong to. Hydronic, other, sanitary. I'm going to choose it to be of the sanitary type. I can choose a diameter. I'm going to choose not 6 inches. I'm going to choose a 4-inch diameter pipe. It's going to place this pipe at level 1. Some offset of level 1. And here's where it gets sort of tricky in terms of thinking about piping. Okay, you have to sort of start thinking about really the physics of the situation and the heights that make the most sense and try to be sensible about this. So if I have a bunch of toilets which are hanging around about 18 inches off the ground, I want this pipe to be pretty low to the ground, or maybe even under the floor level. Sometimes it's in the ceiling of the floor below or something like that. But to have a sanitary pipe work, I have to get it pretty low relative to the toilet. Okay, if it's too high to the toilet, if I try to run the pipe right up here at the same level as the toilets, it'll probably be okay for the sink and for the urinal, but there won't be enough room to kind of put all the elbows and the connections in to keep everything running downhill. Okay, so you have to be kind of careful about just the height at which you put things, and a lot of the troubles we have are just really related to the physics of what can be connected and can't be connected. Okay, so I'm going to put this in, relatively low. I'm going to put it in like it's 6 inches off the ground. Relatively low. I have the notion of, should it slope off, should it slope up, or should it slope down? Okay, and I'm actually going to have it slope down relative to the direction I'm drawing it. It's kind of from start to finish. You can think of that, I'm going to either go from the center here, I'm going to run the sewage this way. I could either come here and slope up, or I come here and slope down, either way. Also, relative to that offset I'm putting in at minus at 6 inches, is it going to be going 6 inches, 5 inches, 4 inches, or is it going to go 6 inches, 7 inches, 8 inches? Either way, in terms of thinking about that, I'll think about it as going slope down. We have a slope value here. We have all sorts of stuff. And does anyone know what the amount of slope you have to put in for a sanitary pipe is?
Minimum 8 1/4 inch.
Okay, let's put that in. Thank you. I'm going to run my little sewer pipe here. Just bring it on down. And that was ever so unexciting, but it sort of works. Go ahead, I'm going to turn it up to a fine resolution. Check this out. Medium, everything's a single line representation. Fine resolution, everything's showing more at a high level. It's showing you the true thickness of the pipes. You might remember as we were talking about structures, it did a very similar sort of thing. Structures, if we kept it at a medium or a coarse, it showed you single line representations. Fine showed you more of the actual physical representation. Okay, let's check it out. Hard to tell here. Sort of see things coming on down. Interestingly, we'll see if it's going to be able to make that connection. Yeah, it's pretty close in there in terms of where I think the out is and where the pipe is, but we'll give it a try. If it's not, I might need to either raise the toilets, although I should have paid more attention when I was placing the toilets. Elevation 1'5". ADA toilet, 19 inches? I'm trying to think. 17 inches seems a little bit light to me in terms of, you should know this. Residential toilets they're lower than ADA compliant toilets. They tend to be a little bit higher. But we'll give this a try and see if this works. Pop back out. I just went through and I ran kind of what I think of as the lateral right now. That part's pretty good. I could try to go through and do something called auto routing, where I give Revit a whole bunch of fixtures and say, hey, you figure out the piping. Okay? And it'd be amazed at how either good or frustratingly bad it does with that task. Okay? Because taking a whole bunch of outputs and trying to figure out the appropriate piping scheme to make it all work right is actually a pretty sizable task in terms of what's going on. There's a lot of variables in there. So what I'm going to advocate you do is, as opposed to just always using auto routing, is go through and always, if you know that there should be a lateral that's going to run through that wall, give it some help. Don't lay out every last connection, but give it the main idea of where you want the big pipe runs to be. Get that part laid out. Okay? Because if you sort of get the big gestures done, what it can do is this. You can take an individual toilet like that, and you can say, I would like to connect it in to, and choose a system that you want to connect it to. See, did it. Connect it into. The sanitary is what I'm going to connect. I'm going to connect it into that system. Not too bad. Let's take a look at what it did. There's actually a lot of little pieces in there. A little piece of pipe, some little elbowy thing, another little piece of pipe, some little kind of transition, ultimately connecting into a T. So did a lot of work for us right there. Let's go ahead and grab another one. This toilet connected into, what are you connecting? Let me connect the sanitary into that system. Not too bad. Let's see what you're going to do. Connect the 2-inch out. So this did something a little bit more interesting. I got like a pipe, an elbow, another pipe. This is some sort of the opposite of a reducer, but a T that we can go through, and what do you call that? A transition. And finally, let's go ahead and get that by. Connect into, I'll take the sanitary. And I connect all those different pieces. Okay, so it's actually doing a fair amount of work there in terms of putting it all together. And again, how can it do that work, or what stops it from doing that work is if you have all the parts and components and elbows and stuff like that loaded in, it is so happy it figures out what to do. If it can't route it, a couple different things might be happening. One might be that in the list of families, if we get down there to all the different pipe fittings, there might not be a good list of things down in here. And if there isn't a good list of things loaded in right now, we can open up the mechanical template and copy all those things from the mechanical template into your project. So you might need to sort of bring them all over and kind of make them available to you. Okay, so we might need to do that. The other thing that happens, though, that gives it a little bit of trouble, let me do this. I'm gonna undo these. Get back to scratch here. They grab that pipe over there and say that. Then go ahead and just raise the whole pipe up a little bit. Okay. Basically, I'm looking to create problems so that you can sort of see what the impact of those problems are. So here I got that pipe. It's running just a little bit high, I think, relative to the toilet right now. I'll take that toilet, I'll say connect into the sanitary. That's interesting. That doesn't seem like a very good connection at all in terms of what's going on. I think we're going to have trouble with that one. It's interesting that it actually let me do that.
Aren't toilets technically pressurized when they flush?
Well, some are. That's actually good. Yeah, a lot of toilets, sort of high-performance ones, are pressurized, so maybe they do have some ability to kind of go uphill, but clearly domestic ones don't.
With that 90-degree.
That looks like a trouble spot. Okay, so I'm trying to create trouble that, things that you may run into in terms of doing this, but here's one that'll probably create troubles. Let me try this. I was pretty generous when I ran this pipe back here. I gave myself a fair amount of room. Let me kind of shove it just right up against the wall. Let's see if it likes that or dislikes that anymore. So here I am. Let me connect it. Again, it's offering that it can do it a lot better than I'm used to it doing. It used to be much fussier about this. In that you have to be sort of watch out in terms of the physical possibility of really whether or not you can make all the different bends and elbows and stuff to really make it all happen. So I'm actually surprised it's being much more forgiving than I'm used to it being. Because in terms of running this stuff, the big problems people tend to have are, that the locations or the heights are just so close that there really just isn't enough room physically to make the connection. So the modeling software tends to complain at you only because, if it can't make it happen physically, it's not really sure what to do. Maybe I'll lower that back down again. We'll connect them back in. Okay, and again, we'll connect those. Sunny, I'm trying to get it to fail, but it won't fail for me. Of course, it will for you. So we'll see how we're doing. Okay, you connect into. So, but the general algorithm is see if you can get the main line down. Choose the type of outs. And do the connections. Okay, in a similar sort of way, hang on, you connect into sanitary, let it do its thing. Okay, we'd like to run some water to supply these fixtures to, so you can think about how you want to go through and do that. Let me pop this back up to the top. I'd like to run some hot and cold water pipes in that wall also. The hot and cold water pipes I could put low, I could put high. The nice thing is they can kind of be at almost any level because they are pressurized. just really wherever we can physically run them so that they're not interfering with too much. I'll put them higher so that they're not getting in the way of that sewage pipe, the sanitary pipe, as it's moving along. So let's place some pipes there. I'll choose a pipe right here. Oh, now for this pipe, let's go through. I'm going to say it's not going to be a sanitary pipe. It's going to be, domestic cold water. In terms of its slope value, I don't really need to have a slope on this one, so I'm going to just leave that turned off. Okay, I'll just run it. Now 4 inches feels a little bit high. How big this pipe needs to be kind of depends on the number of fixtures it's ultimately going to feed. So I'll put a 1-inch pipe in there right now, but it's going to depend, it may resize it. The system will help me size it if I need to put something in bigger later. So I can change it there, I can change it up here. In terms of the offset relative to the floor, I'm going to put it up pretty high. Like 5 feet off the floor or something like that. So I'm going to run this little 1-inch pipe back here. That's my hot water line. Or cold water line, excuse me. Let me do another one that's going to be very similar. Let me do the hot water. Again, slope off, about 5 feet. Maybe I'll offset this a little bit vertically, just so that if they were perfectly horizontal with each other, there might be some interferences as I try to tee off. Let me make that 5'3" or something like that. Again, we gotta help it a little bit in terms of thinking about how the system would be planned out to minimize the number of interferences. Yeah, the model will try to be as smart as it can be, but the more you can sort of set it up so that you've planned out where some of these different systems are going to run and how to avoid the conflicts, the better. So here I have my hot and cold. Let me orbit that around a little bit so you sort of see that better. Okay, and in the same sense there, I got that toilet. Let's go grab it. I will connect it into the blue pipe. It's doing it. Notice this time it didn't ask me what it wanted to connect into, because there was actually only one thing that wasn't connected. I already connected the sanitary, so it was implicit at that point. The only thing left over was to connect the cold water. Same thing over here. I will do a connect into the blue pipe.
Why are you running the hot water all the way down and it doesn't even connect to the sink?
Good question. I don't really need to, do I? No, I could actually probably stop that shorter. There's nothing about it. Actually, this time it did sort of a funny job of routing. I don't know why it would route it all the way back there. I'm going to undo that in just a second. But no, I don't really need to run the hot water all the way down. So even in here, per your suggestion, I could go ahead and say, I just only needed about that far. We get that urinal in there. That's very odd to me that it's trying to connect them to the end as opposed to actually put it in there. It's trying to connect it to the open system as opposed to actually just connect it into, hang on. It thinks that opening is being opportune. Maybe to avoid that, I'll extend these further off so that looks less opportune as opposed to putting in a fixture or an L. Actually, what I should do is actually put in a riser though, which would be truer. Okay, let's see if we can connect the sink in. Let's take the hot water to the hot water. Okay, that did pretty good. Let's take the cold water. Okay, that was a little bit better. What I ended up having to do was just make the end of the pipe less attractive.
You made it longer?
By extending the end of the pipe further away, as opposed to being, hey, I'm an open connection, connect to me. Yeah, actually, it would have been less attractive if it was already connected to a riser of some type.
So those should don't slope, right? The hot and cold water?
Yes, they don't have to be sloped.
They are.
Oh, it's interesting. notice the bottom of this one's still kind of, I'm going to take out a pipe segment there. It's doing something funny. Now, you can take out segments of pipes. All these are just little connections. Even here, that looks like it's some sort of little like elbow or something like that in there. You know, we can go ahead and just join segments of pipes. I'm going to join that back in. I'm going to put the riser in there in just a second so we can join that all back in. But yeah, it tries to be pretty smart about kind of connecting it all together. But what I want to sort of leave you with is, so now it's sort of loose end of pipe waiting to kind of happen over there. You know, if it's fighting with you and it's trying to do stuff and you know in your own sensibility, okay, that's not really a sensible thing to do, yeah, take out individual connections, take out little individual segments of pipe. You may have to do a little bit of negotiating and arm twisting with it sometimes to really get it to route it exactly the way you want to. Because it's trying to be smart as any computer program can be, but the complexity of running the piping is actually a little complex, and doing it completely automated may not be realistic. So, you know, don't be afraid to kind of, if it's having a hard time figuring something out, you know, be a little hybrid about it. Figure out part of it for it and see if it can be smarter. If it's still not quite figuring it out, take it even one step further. You can run those pipes really with great control to wherever you want them to be. What Revit's really good about figuring it is if you got a 4-inch pipe and you got a 2-inch pipe, how to connect them together. It's good about figuring out like what sort of elbows and connections and transitions it needs to put between those things. But in terms of the actual routing locations, if it guesses wrong, don't be afraid to tell it otherwise. Okay, because, you know, like most computers, it's only as smart as it kind of could pretend to be. There's not really, there's no easy way to do it completely automatically. Okay, so let's go ahead. Let us break for now. I'll take a question, we'll break, and then when we come on back, I'll put that riser in and we'll take a look at HVAC systems because they're very similar. What you got?
Is it like worth it to go through and adjust each component? Like if you wanted to do every section and pipe yourself, would that be exactly the way like a plumber would put the pipe in to exactly those specifications, or are they going to make decisions in the field?
Oh, this is really, and this is kind of a very interesting kind of question. Yeah, it depends on really the degree of precision required by the construction. In like residential construction, we pretty much say, here are the locations, plumber, figure it out. Okay, and they tend to do a pretty good job relative to, you know, where the structural elements are. We might have to provide some guidance, but they'll often figure that stuff out. You know, as you get to sort of more and more precision or more precise types of construction, you know, you may get down to the point where everyone really does. Yeah, you're figuring out exactly every bend and elbow and things like that. So, for example, if you're on like on a large hospital project and there's really just pipe running every which way to handle all the different systems, you may, for an individual room, figure out every last elbow, every last transition, exactly where they're needing to be running down to that last inch, because it really has to be controlled at that level. What will tend to happen in a scenario like that is you may figure it out for 1 or 2 rooms, and then those rooms will be copied and arrayed around. So, you know, the degree of control you want to put in really sort of gets into how much control the finished product needs, and some jobs they really do care about every last inch, and you'll need to do it at that level. So it just kind of varies. Like, you know, when they were doing Y2E2 or they were doing the long center here, something like that, yeah, no one really measured every last inch of every last pipe. But in a lot of plants where every last inch and every, yeah, it does count, yeah, those actually are figured out to that nth degree. So as much as seems to make sense for the degree of control you need. Okay, great. Let us go ahead and break for about 5 minutes. Come on back. When you do come on back, we are going to continue the story with we'll put a riser in here and ultimately go through and put some HVAC piping in here too. But that's the general principle. It's really not too bad.